Hello everyone, welcome to my YouTube channel. So today I am going to solve the Tifr GS 2024 problems. I'll solve part by part and make a different video. So let's start. So this is the provisional answer key paper, and so I'll solve according to this paper. So the first question says that what is the number of even positive integers n such that every group of order n is abelian? So it is given that n is a positive even integer, right? So n equal to 2k, n equal to 2k, and for k greater equal to 3, there exists a group of order 2k which is non-abelian. Sorry. Which is non-abelian. That is basically dihedral group. Okay. So for n greater equal to 3, for k greater equal to 3, there exists a group of order 2k which is non-abelian, and that is basically dihedral group. And for k equal to 2, n equal to 4, and there exist exactly two groups of order 4 which both are abelian, which is z4 and k4, right? And for k equal to 1, that means n equal to 2, there exists exactly one group which is z2. That means 2 and 4 are the only possible two integers. 2 and 4 are only positive even integers such that any group of this order is always abelian. Because if you choose k to be greater or equal to 3, that means n to be any positive integer greater or equal to 6, you can always have a dihedral group of order 2k. And dihedral group of order 2k is always non-abelian. It is so this question is very easy problem, and it's a doable problem. Now come to the question number 2. It says that n be a positive integers, and we are considering the set that is a collection of all polynomials of degree at most n, real polynomials. And then we are considering the set collection of all roots of the function e to the x minus gx for a fixed polynomial of degree at most n. And then they ask the minimum cardinality and maximum cardinality of this set. So you can do it in general, and for in general argument it is better to use induction on n. So I'm not going to solve it in general, but it is your task to solve in general, but I can give the idea the how to solve during the exam. So by taking n to be 1, just because if you choose n is 1, then all four options becomes different, right? So whatever options you will get correct for n equal to 1, you can give the correct answer. Okay, so let's choose n equal to 1. Let n to be 1. Okay, and then polynomial, say if I write it as px, it looks like ax plus b, right? Ax plus b, right? That means so ax plus b equal to c gives us a straight line equation in R2, right? So I can solve it directly, I can solve it graphically also by just drawing the graph. So say this one is x-axis and y-axis, okay, and this one is basically, say, I think I did a mistake. So this one is basically e to the x, graph of e to the x. Okay, and now you can draw any straight line. uh, so it asks, basically it asks that what is the maximum number and what is the minimum number. If you draw a straight line here, it cuts the graph of e to the x. So it is pretty obvious, if you choose say any straight line, uh, say passing through origin in this way, then it clearly uh, does not cut e to the x graph. Or in particular, if you choose x equal to 0, that is also a polynomial, right? Then e to the x equal to 0 does not have any solution, any real solution. So that is that means e to the x equal to 0 does not have any solution. That means minimum number of roots of e to the x minus this polynomial is 0. And if you choose a straight line like this, sorry, it's not working properly. It's better to choose. So this tends to 0. Okay, this is e to the x graph. If you choose a straight line in this way, that will cut exactly 2 points. You can also take a value of e to the x at some point, and you can manipulate to get exactly what kind of straight line you can take, so that it gives you this it gives you exactly two solution, I mean exactly two cuts. Okay, but the answer is that max for n equal to 1, maximum number of solution of e to the x minus gx polynomial is 2, and minimal number of solution is 1, sorry, 0. So that's why option 2, I mean option B will be correct. Okay, so you can do general argument. I can give just a hint that you can, since e to the polynomial is differentiable and e to the x is also differentiable, and derivative of e to the x is always e to the x, so you can set up this argument and take the, say, check the roots, number of maximum number of roots of the derivative, and then you can generalize the argument for roots of that function to, by using that mathematical induction concept, induction argument, and you can show that the maximum number of roots will be n plus 1 if you fix into a positive integer. Okay, that you can directly do. I'm not going to tell what is the exact how can you do that exactly, but it is pretty obvious, you can do it. So option B will be correct. Now come to the question number third. Question number third says that V and W non-zero finite dimensional C vector spaces, and so you are considering C linear transformation from V to W and considering R linear transformation from V to W, and you can see that forms a vector space, and you are say considering that, seeing the dimension of that vector space over R, then you are concluding that what is the relation will be a in between M and N. Okay, so some students have doubt in this question, but I'm going to solve this problem. Okay, so it is given that V be a finite dimensional vector space over C, right? So you can think V to be isomorphic to some C power P, right? Isomorphic to some C power P, and W to be isomorphic to some C power Q. That means dimension of V over C is P, and dimension of W over C is Q. So if you consider all C linear transformation from V to W, consider all C linear transformation from V to W. Okay, so any C linear transformation you can view it as you can see it as a matrix, right? So then you will get the matrix. If you consider the matrix representation of that linear transformation, that gives you a matrix, and then matrix will be order P cross Q, right? Because dimension of sorry, Q cross P, not P, because it is V to W. So it gives you Q cross P, right? Because the linear map is from CP to CQ. So so the matrix representation will be Q cross P. And any matrix So Q cross P matrix over C, that will also give you a linear transformation. So it is vice versa. So dimension of C linear transformation from V to W, C linear transformation from V to W over C, dimension will be PQ, right? Now it says that you are considering all C linear transformation, but you see it as a R vector space. So over C the dimension is C linear transformation over C, that dimension is PQ. So whenever you are considering it over R, that means dimension becomes 2PQ, right? Over R, dimension becomes 2PQ, because it is collection of all C linear transformation from V to C, and over C, that space means collection of all C linear transformation from V to C, V to W, over C that dimension is PQ. But when you are considering it over R as a real vector space, that dimension becomes 2PQ. That means M equal to 2PQ. M equal to 2PQ. Okay. Now come to the next part. So then you are considering or R linear transformation. Now V is isomorphic to CP. Since you are considering it as R linear transformation, so you have to view V as a R vector space. Then R vector space dimension will be R2P, right? Dimension will be R power 2P. Similarly for W, dimension will be R power 2Q, right? So for V, dimension will be R power 2P, and for W, dimension will be R power 2Q. Now you are considering it as a R vector space, right? Then what will be the dimension? 2P cross 2Q. And here entries are from R, because I'm already considering V to be a R vector space. So here entries are from R, so we need not to consider anything. So that is the so the dimension. So matrix representation becomes R 2P cross 2Q matrix, right? Then dimension will be 2P times 2Q, that is 4PQ. 4PQ, right? So n equal to 4PQ, which is 2m. That means n equal to 2m will be the correct answer. N equal to 2m will be the correct answer. Okay. So I think many students have doubt because of this R linear transformation, C linear transformation. But you have to think that whenever you are considering, so try to think everything as a matrix representation. So whenever you are considering the C linear transformation, you can view V as a C vector space. And you are considering C linear transformation means, so matrix gives you over C matrix, right? And so if you think it an over C matrix, then each entry is of the form A plus IB. Then whenever you are considering is over R, that means dimension becomes twice times that. So 2PQ will be the dimension. But in the next case, you are considering R linear transformation from V to W. That means you can view V to be an R vector space. How can you view? V is a C vector space and V is isomorphic to C power P. Then when you are considering it over R, this becomes R power 2P, because for each component C you will have two dimensional, because C is isomorphic to R2, right? So that is what you have to do. So this problem, I think many students did silly mistakes. It's not difficult, but it's a good problem. Now come to the problem number 4. Okay, come to problem number 4. So problem number 4 says that this is the easiest problem, I think. Is a collection of all sequences that satisfies this condition: a k plus 2 is 2 ak plus 1 plus ak. Okay, so a k plus 2 is 2 a k plus 1 plus ak. That means a2 2 a1 plus a0, a3 2 a2 plus a1, that is same as 2 into 2 a1 plus a0 plus a1. So a4 is basically 2a3 plus a2, that is same as 2 into 2 into 2 a1 plus a0 plus a1 plus 2a1 plus a0. So basically any an is basically C1 times A1 plus C2 times A0 for some real number C1 and C2. That means you can write, since this is a relation, so if you fix the value of A0 and A1, then you will have all the values of the other terms an. That's why dimension will be 2. So that's why dimension will be 2, because the choices of the two choices is choices depends only on A0 and A1. So dimension is 2. It is obvious. It is easy one problem. Now come to the problem number 5. It's a good problem. So f is a continuous function from closed interval 0 infinity to r, and it is given that limit of some integral is 2, and then you have to find out the limit of some another integral. Okay, so let's see. So integral 0 to 1 f of x plus n dx, right? Let x plus n to be z, dx equal to dz, then n to n plus 1 fz dz, right? This becomes 0 to 1 f of x n. So an to be this, it is given that limit n goes to infinity an equal to 2. It is given. Now 0 to 1 f of nx dx, let nx equal to t, n dx equal to dt. So dx equal to dt by n. So you will have bn, say this one is bn, bn to be bn equal to 1 by n 0 to n ft dt. So we need to find out limit of bn, right? We need to find out limit of bn. We need to find out limit of bn. So we have bn to be 0 to n ft dt divided by n. That is same as, so 0 to 1, so limit n tends to infinity, same as limit n tends to infinity ft dt minus 0 to n ft dt divided by n plus 1 minus n by Stolz-Cheshire theorem. I am not going to state what is the exact statement of this theorem, but I think everyone knows this theorem because this is a very important theorem. So if you know Stolz-Cheshire theorem, you can apply it. You should know that what is the condition when you can use here the roles of n in this below part is very important, okay, to apply this Stolz-Cheshire theorem. So then what will you have? Limit n goes to infinity, this becomes n to n plus 1 ft dt divided by 1, right? That is basically same as limit n goes to infinity n. That means limit of bn and limit of n both are same, hence the answer is 2. So limit of uh, that integral, sequence of integral exists, and the value is exactly 2. Okay, so here the important roles plays by the Stolz-Cheshire theorem. Okay, so if you know Stolz-Cheshire theorem, then you can directly solve this problem. This is pretty obvious. So that is exactly the solution. So I'm going to make another video later. Okay, in other parts. These are first 5 problems. Okay, thank you.